So we're back with part two of this lecture. So remember what we're talking about here. We're talking about rational functions, and today we're going to focus on the modeling aspect. So remember, a rational function is just a polynomial divided by another polynomial, which of course the bottom polynomial can't be zero. We want to talk about modeling with these rational functions. So let's take a look at an example. We're going to follow our 4 steps where we do a picture, equation, solve, and test. And so here we'll start our picture. And what it says is we have a contractor constructing a duplex as shown in the picture below. The overall area of the rectangular floor of the duplex is 2,400 square feet. So that's what this number is right here. I'm going to make it a little bit bigger. So we have 2,400 feet squared. We want to find the dimensions of the duplex that will minimize the amount of material needed. So what do we need to find? So find dimensions that minimize, so min, material. Okay, so we need an equation. So we need an equation, we probably need some variables here. So of course let's call the horizontal x and the vertical y. Remember, you don't have just 2 y's, you actually have 3 because you have this inside piece here, which I can color if you like. So instead of 2 y's, you actually have 3, so you have this interior piece right here, which we can call y also. And so to find the dimensions that give you use the least amount of material, we need to find a formula for the amount of material. So basically the idea is just the perimeter. That's the amount of material. They give us the area, so we're probably trying to find the perimeter. And to find the perimeter, you just add up all the sides, including the one in the interior. So all you have is just 2x's plus 3y's. We would like to graph this thing, but we can't graph it because we have 2 variables, but that's okay. That's why they gave us the 2,400 square feet. And we can find the area of this thing. So if you want to find the area of this thing, you just simply multiply it, the length times the width, with it's just x times y. So it's x times y. And we can solve this for y by dividing out by x on both sides. And so what do we have? We have 2,400 divided by x is equal to y. And so we can come over here, and wherever we see y, we can replace it with what it's equal to here, 2,400 over x. And then we'll have our function, but not in 2 variables. We'll have it in a single variable. So we have 2x plus, and then 3 times 2,400 over x. And so this is equal to 2x plus, and then 3 times 2,400, I think should be 7,200 over x. And so there's our formula for the perimeter. And then we can use this formula now. And so we can use this now. And the way we're going to use it is we're going to solve our problem with it. And so what we'll do is we're going to graph this thing on our graphing calculator. So hit on, and we'll hit y equals and clear this out. And we'll type in 2x plus 7,200 divided by x. And we'll need to make our window, so here's where we have to think a little bit. So for our window, x, remember, is the length of this duplex. So let's make it 0. And then I have to think a little bit. So like a duplex, you know, it's sort of like the length of a house, basically. And it's kind of like 2 homes put together. So maybe I'll do, let's do like, we're going to make something a little bit bigger. So let's do like 300 feet. I think that'll be nice. You want to make it nice and big, bigger than 100 feet probably, but not too big. You know, let's see what 300 looks like. So then we'll zoom, and we'll do zoom fit. So I'm going to scroll up the zoom fit, or you can hit 0. And I want to see this thing come down and go back up because it's a minimum. And that looks pretty good. It came down, it came back up. Now it looks like it touches the x-axis, but remember, it doesn't really touch it. We just zoomed out really far, so it looks like it touches it. It doesn't actually touch it. If you zoomed in more, you'd see that it's above the x-axis, really. But I want to find that minimum. But I'm gonna trace this over here. So the idea is it came down, it goes back up. I went from 0 to 300. I'm looking for that minimum right there. So I want to find this minimum down here. And so what is that? So I'm gonna hit second trace, go down to number 3 for minimum. it's going to ask for some bounds, left bound and right bound. Now I can scroll over, but it's hard to see where I'm scrolling. So I'm just going to hit 0 because I know 0 here is to the left, and hit enter. And for a right bound, I'm just going to hit 300 because it's clear to me that 300 is definitely on the right of that minimum. And hit enter for a guess, and it should pop right to it. So it goes to the point 60, 240. So let's write that down, and then we'll interpret what that is. So right here, we have 60, and then comma, 240 on our calculator. And so now what we need to do is we need to find the dimensions. So what are the dimensions? Remember, the dimensions, so when I think about dimensions, like, well, I have dimensions, you know, so I wear maybe a large t-shirt, and I have pants which are like 36, 32 or something, and I have shoe size about 11.5. So those are like my dimensions. Over here, the rectangle has dimensions. It has a length and a width. And so basically it's saying find x and find y. And so now the 60 right here that I found, that's actually my x. So I know that my x is equal to 60 feet. Whereas my y, I have to be careful. Because for my y, some people may say it's 240, but that's not my y. The 240 is actually the perimeter. Right? My y up here is found by taking 2,400 and dividing it by my x, so dividing it by 60. And if you do that, you'll see that it's not even close to 240, it's actually 40 feet. And you do that on your calculator if you want to. So there's my answers. I have 60 feet by 240 feet. Well, not by 40 feet. I'm sorry, by 40 feet. Let's look at, and then to test this, if you want to test it, you could actually put the numbers in here. So, you know, put a 60 here, a 60 here, a 40 here, a 40 here, a 40 here. You add them all together. You multiply 60 times 40, you should get 2,400, and that should be the minimum. So you can kind of test it a little bit, although it's a little bit hard when you use technology to solve your problem, because that's actually what I typically use to test things. Just as a footnote, you guys should know that, I mean, you can do this with calculus without using a calculator, and so that's what we normally do. These optimization problems, you'll do them again in calculus, but we can kind of bypass calculus here and use a calculator and still kind of get the gist of the problem to kind of prepare you for calculus. Let's look at the last problem, example 4. And so in this one, it says a landscape architect plans to enclose a 3,000 square foot rectangular region in a botanical garden. They'll use shrubs costing $15 per foot along 3 sides, and fencing costing $10 per foot along the 4th side. And we want to find the minimal cost. All right, so I always just sort of read a problem once. I'll often underline what I think is important. I don't get much from it after the first reading, but I do know there's a rectangular garden, which I can draw a rectangle. So you remember, you want to start with your picture. So we start with our picture. So here's my rectangle. I know it's 3,000 feet squared. So we all write 3,000 feet squared. And remember, because it's squared, that's not the perimeter. That has to be the area. Yeah. They'll use shrubs costing $15 per foot on 3 sides. So let's do some shrubbery, and let's use green. And they're going to do it on 3 sides. It does not matter which sides you put it on, but you have to put it on 3. So let's put it on the top and the bottom, and then let's just put it on the right hand side too. And so remember, the shrubs here, these are my shrubs, they're going to be $15 per foot. And then it says you have a fence on the 4th side. So here's my fence right there. And so my fence is $10 per foot. It's a little cheaper. And I want to find the minimal cost. So find min cost. So find min cost. All right, so let's do that. Let's find a cost equation, a formula that models the cost. So let's do C. And this can be a little bit tricky at first. So the idea is you have 4 sides, and each side costs something. And so we want to figure out the cost of each of these sides. So let's simply start with the bottom side right here. So how much would this side cost if it's x feet long? Which means that'll be x feet, and that'll be y feet, and that'll be y feet. So how much would this side cost? And if the answer doesn't sort of just come to you, what you need to do is you need to sort of actualize this problem and say, okay, well, let's pretend that x is a number. Let's pretend it's actually 1 foot right here. How much would it cost to put shrubs on 1 foot at $15 per foot? And you'd say $15 if that was 1 foot. And then let's generalize, so maybe a little bit more. So 2 feet now, then it'd be 2 times 15. 3 feet, 15 times 3, because 3 feet, 3 15s, because $15 per foot. 4 feet, 15 times 4. 5 feet, 15 times 5. So x feet, 15 times x. Right, so you can kind of force your brain to kind of think of the formula by doing cases. I call this actualizing the problem, coming up with some numbers and thinking what you would do with those sort of numbers. And if that's 15x, the rest of this is actually pretty simple. This is y, so instead of 15x, you have 15y. You go across the top again, across the top at the same distance again as the bottom, so it's just going to be 15x. And then you have to be a little bit careful because you're going to go down y, but it's not going to be 15y because you're doing fencing. So instead of 15, it's going to be 10. So 10y. And so my cost function, you have 15x and 15x, you have 30x's, plus 15y's and 10y's, which give you 25y's. And we're always in the same situation now. You want to graph this, but you can't because it's a function of 2 variables, x and y, so you need to get rid of one. But that's okay because that's where this 13,000 is going to come into play. The 3,000 is going to come into play. So this is 3,000 is equal to the length times the width, so x times y. And we'll solve this for y, so we'll just divide both sides by x. And we'll get 3,000 over x is equal to y. And so what we can do now is we can simply plug in 3,000 over x in for y. So we'll take out that y and replace it with it's equal to in terms of x. And so c will be equal to, and we'll have 30x plus, then you'll have 25, then all times 3,000 divided by x. And we can clean that up a little bit. So my cost will be equal to 30x plus, then you take 25 times 3,000 on your calculator, and you'll see that's 75,000 over x. And now we can graph this, so we can solve this, use this formula to solve this problem. And so we're going to graph it on our graphing calculator. So you're going to hit y equals, I'll turn it on, y equals, clear this out, and then we have 30x plus 75,000 divided by x, which you may want to note this is a rational equation because you're rational function because you're dividing by x. So if you did find a common denominator here and move these together, you see you have a polynomial on top divided by a polynomial on bottom, so it is a rational function. We need to make our window, so we'll start our window at 0. Remember, x is the side of this botanical garden, so it needs to be a pretty big garden. 300 feet's pretty big, so I think I'll keep it at 300 and see what happens. And so then I'm going to go to zoom and zoom fit. Hit enter, and all I want to see is it go down and come back up. There it does. So it comes down and goes back up. Remember, it looks like it touches the x-axis, but it really doesn't. We're just zoomed out pretty far. So what I can do is I can draw my picture over here to show my work. So I get partial credit if I make a silly mistake, and it goes back up. I went from 0 to 300. I'm looking for the minimum. So I'm going to type down minimum here. And on my calculator, I'm going to hit the second trace button to get to the calculate menu. Go down to minimum. Left bound is 0 because clearly 0 is to the left. Right bound 300 because clearly 300 over here is to the right. Then guess, just hit enter and I'll jump right to the point. So 50, comma 3,000. So on my picture, I can put 50 comma 3,000. And of course, I need to find what? I'm looking for the minimum cost. And so remember what the minimum cost is. It's not the input, it's the output, because it's C equal to. And so I can write my answer now, if you like. My answer is the min cost is $3,000. So $3,000. Check. Okay, and I think that does it. I guess I should have written minimum up here just to show my work. Not sure if I did that or not. So write minimum up there. But do notice these are rational equations because you have x in the denominator here. You know, if you look at this, if you get a common denominator, you can actually rewrite this. You don't have to do this, but you could actually rewrite this as 2x squared plus 7,000 all divided by x. And so it's clear you have a polynomial on top and a polynomial on the bottom. So it is a rational function that we're working with. And that's it. That ends this video.